Hello everyone. Firstly, I would like to introduce all my teammates to you. Muhammad Riaz, and then comes Riyan, Hanish, Purna, and Akash. Our team is mentored by Dr. Deepika Garu, and today I'm gonna say about our model AgriGPT. As you can see, it is an AI agricultural assistant. Well, talking about our project, agriculture is the big backbone of India, but the farmers in India, they still depend on the traditional knowledge. Even though there exist many digital tools, they rely on the static information and they fail to respond to real-time changes. If we take an example of market data, or else if there are any pest outbreaks, like recently we have seen in Telangana, there is a pest outbreak of urea. So our AgriGPT, it is an attempt to bridge this gap between the modern AI techniques as well as the domain knowledge, so that it supports decision making a little bit far better than the static knowledge. Talking about the project overview, it's a domain specific AI which is useful for farmers, students, and also the agricultural professionals. Yeah, there are, unlike traditional chatbots, it is a rack combined with the agent. Well, it decides when to use the static knowledge and when to fetch live data such as weather data, market prices, and water levels. Well, talking about the architecture, if you see, this is our previous architecture where we have the data sets which are of CSVs, PDFs, and CSV formats. We have converted them into the Word embeddings and stored them in a vector database. Well, when there is a query given by the user, then it goes to the rack system and then it retrieves the data from the database, and any external API like live data of anything like weather or market price will be fetched by the AI agent, and both combinedly will be giving it to the LLM, and the LLM generates a response in textual format. Talking about the new or the architecture, we have a customized data set which have been collected through many different government portals as well as university textbooks and all. Also, there are some of the local surveys also which have been pre-processed by using Python, where data pre-processing is done. What we have done in the data pre-processing is we have removed boilerplates, we have removed the excess punctuation, and also lowercasing of all the text is done so that there will be no confusion. And now after doing the data pre-processing, the data is clean, clear, which have been divided into chunks, and then they have been converted into embeddings using sentence transformer model, and then stored those files into the FIRES vector database. FIRES represents Facebook AI similarity search, which is very efficient for retrieving similar data. This is all about the dataset. Coming to the front end, a user gives a query through the web interface which goes to the backend agent. Then an agent is called. Now here agent is the master of our model, because agent is the decision maker whether the query needs any live data like live market prices or any location or weather of that particular location. That is called. And also RAG is also attached to the agent as a tool which retrieves the static database, which retrieves all the static knowledge regarding the agriculture. It takes the data from RAG as well as if there any need of any live data, it takes both of them and it gives it to the response LLM. In our case, we have attached Gemini as our response LLM. It is given, and then the answer is given back to the backend. Backend, it gives the answer to user through the web interface. So these are all the technologies that we have been using for building the Agri GPT. For the backend, we have used framework, Fast API, UVCon, and for storing the credentials of the user, we have used SQLite and SQL Alchemy. And for accessing the email accounts, we have used Google Auth. And then APIs for loading the model and getting the keys of open weather like live data. For configuring all the things, then we have used pydantic, and for building the agent and the model we have used python. And then for doing embedding sentence transformer, this model all mpnet base v2 was used. For storing the data, that embedded data, we have used phi, so that it is very efficient in similarity search. And data tools like numpy, pandas and scikit-learn were used for the model. Coming up to the front end, we have used react. For the framework, we have used the React.js, React Router DOM, and the context API like auth and the theme. For fetching APIs, we have used APIs, and then UI and was we have used React icons and web speech API. For styling, we have used plain CSS and also the component levels. So these are all some of the technologies that have been used while building the AgriGPT. As mentioned earlier, AgriGPT, it is domain specific, it is integrated using RAG and also has live data. Many people or many farmers in India have very minimal access to the consistent agricultural data. So our AgriGPT tries to bridge that gap, to cover that gap between the expert knowledge and the access that farmers get, so that there will be very less risk of crop failure. So this is all about the knowledge. And what sets our AgriGPT apart from all other traditional chatbots? Well, it is a multi-tool agent. It not only has the static knowledge base, it also has the live data of that particular day or date whenever the user is querying. And it is also enabled local location intelligence and also the production upgrade. This explains how our data was made ready for the RAG. Like we have collected the data from different government portals and agriculture related websites. Then we have done pre-processing, like we have cleaned the data, we have lowercase the data and removed any excess noise before chunking and embedding. While in the chunking process, semantic chunking with overlapping windows, this was done, and then embedding was done using all MPNET base v2, which is a sentence transformer model. It has done all the embedding process and then stored that data in the FAISS, which is Facebook AI similarity search. Well, it is useful in, and it is very efficient in fast similarity search. Well, this is the agent decision logic. Whenever a query is passed to the agent, first it checks the scope, whether if it is an agriculture related query or any out of scope. If there is an out of scope, then it simply says that the query you have asked is an out of scope and I cannot provide that. And if it is any query which comes under agriculture, then it goes to the step 2 where it selects the type of tool according to the query. If the query requires any static knowledge, then the tool drag is called. If it is also there is any requirement of weather or market or water or any kind of tool which we have added to our agent, then all those particular tools have been will be called. If there is any use of location, then the location is extracted and then context aggregation is done. So this is all about the agent decision. So firstly, it asks the user about giving the access to the location. I'll allow this for the first time. And when coming to the interface, we have all the buttons like it's the chat history, and we have to click here for the new chat, and we have live weather, and then let's give location access and then reload. We'll get the live weather, and then this is the white mode, and then this is the dark mode. Let's ask a query. So I've asked the query, what are the practices done for paddy? Yeah, it takes a while for giving the question. Until then, see, these are the all the options. So we have got the answer. So this is the response generated by the LLM, and we have all other icons like help, settings and all. This is all about the working of the model. For evaluation process, we have taken four models that are OpenAPI, GPT-4o Mini, Mistral, and then Metalama, Google Gemini 2.5 Flash. We can clearly see the domination of the Gemini 2.5 flashlight because it's very accurate, like it's around 90, and then the latency is very low, which is very good for us because the answer or the response generated will be in no time. And the cost of this model, as all these are the paid models, the cost of Gemini is also very low. We have evaluated it based upon the sentence similarity and also the answer correctness and the time taken to response generation, also documents found. So we can clearly see that the Gemini 2.5 Flash is dominating, so we have decided to add that as our response LLM. So these are the key improvements over the Agro LLM, which is our base paper. Our base paper does not have the multi-tool agent. It was simply a RAG system, and the response was generated through the static knowledge which was already embedded into the RAG system. But our model, it has a multi-tool agent so that it integrates weather, market, water, and pest APIs, so that it can retrieve the live data. And then scope detection, like our model says if the query asked by the user is out of scope or in scope. If there is an in scope, then only it responds to the query, or else it simply says that the query asked is out of scope. And then we also extracted the location of the user for the accurate answers according to the location. And then we also have API key rotation so that there will be no fluctuations in the answer, as it manages the API rate limits and production ready. And it also has clean interface because we have added all the complex details, providing plain text output for the user so that he will not be confusing. So these are the key improvements over our base paper Agro LLM. Coming on to the most important sector of the topic, the applications. The Agri GPT, it has a large of applications, like it helps in farmers who reside in rural areas who don't have that easy access to the agricultural data. And also it acts as an AI tutor for agriculture education for the students and the professors who are pursuing the agriculture related education. Then it is a perfect AI tutor. Then it becomes very important for the people who need responses according to their particular location, because our AgriGPT, it generates the responses according to the that particular location given by the user. And also it can also be used as a personalized farming knowledge system that can be useful for long term farm planning, so that there are very least risks of crop failures. So these are some of the real world applications, and there are so many to name again. So these are some of the challenges that I've been came across while doing the model or building the model. So some of them are like we were out of limits, like our API rate limits were exceeding. For that we have come up with a solution called API key rotator using round robin approach, which manages multiple API keys with cooldown periods, like it adds sleep for each API key so that there will be no exceeding of API limits. And then the second challenge we came across is location mismatch, where the output generated was very inconsistent according to the user's location. For that we have built a robust system for mapping. And then the most uh, cha- challenging one was the live data, because we were not getting reliable live data from APIs for all the regions. It was very difficult to get that, and some of them were even paid API keys. For that, the solution we have come up with that. For now, we have just given temporary CSV files, like the offline data. Once we get the live API keys, we can attach them to the model. Even though there were many challenges that have been resolved, some of the challenges that are not resolved are like our model, it is for now currently it is only a English only interface, and it is highly reliable on static data sources, and also there is no functionality where the user can upload the image. So these are some of the current limitations. What are our future work that can be done is like it can support for multiple regional languages, not only for English, and also we can add some voice input and output capabilities, and integrating it with the real-time soil sensors can also be done, and it also can enhance crop yield prediction models and advanced disease detection algorithms, so that it can even perform better in the future. So these are some of the future work that can be done, but due to the time constraints and all the other factors, this has been not done. So wrapping up the session, so this is all for about the model. So well, that's it all about the Agri GPT. Thank you so much for watching the video. Thank you.